In the heart of London, in 1928, a cluttered, unassuming laboratory at St. Mary's Hospital was about to become the stage for one of history's most significant accidental discoveries. This is the story of a man whose untidiness changed the world forever. His name was Alexander Fleming. Fleming, a Scottish bacteriologist, was known for his brilliant but often disorganized mind. His workbench was a chaotic landscape of petri dishes, beakers, and scientific notes. He had just returned from a 2-week holiday, and a tedious task awaited him: cleaning up a pile of petri dishes he had left stacked in a corner, each one a culture of the Staphylococcus bacteria. As he began sorting through the dishes, one caught his eye. It was different. A splotch of blue-green mold, similar to what you might find on old bread, was growing in one of the dishes. But that wasn't the strange part. The truly remarkable thing was what was happening around the mold. In a clear, perfect circle surrounding it, the usually resilient Staphylococcus bacteria had been completely wiped out. It was as if an invisible barrier had formed, a no-go zone for the deadly germs. Another scientist might have simply tossed the contaminated dish, but Fleming's curiosity was piqued. He saw not just a ruined experiment, but a profound mystery. What was this mold? And what was its secret weapon against one of humanity's most common bacterial foes? He carefully took a sample of the fungus and began to cultivate it. He identified the mold as a rare strain of Penicillium notatum. He then set out to isolate the juice it was producing, the substance that was so lethal to bacteria. He called this substance mold juice, before eventually settling on a more scientific name, penicillin. Fleming discovered that this penicillin was not just effective against Staphylococcus, but a whole range of harmful bacteria responsible for diseases like scarlet fever, pneumonia, and meningitis. Even more astounding, while it was a powerful killer of bacteria, it seemed to be harmless to human and animal cells. This was the holy grail of medicine, a substance that could attack an invader without harming the host. Fleming published his findings in 1929, but the scientific community was largely unimpressed. His paper was met with a resounding silence. Why? Well, Fleming was a brilliant bacteriologist, but he wasn't a chemist. He struggled to produce penicillin in large, stable quantities. The mold juice was incredibly difficult to purify and lost its power quickly. For over a decade, Fleming's groundbreaking discovery remained a scientific curiosity, a footnote in a medical journal, its true potential locked away. The world continued to suffer from bacterial infections, and simple cuts or scratches could still lead to fatal consequences. But history wasn't finished with Fleming's mold. The story of penicillin was about to enter its second, dramatic act. As World War II cast its dark shadow across Europe, the need for a weapon against battlefield infections became desperate. Soldiers were dying not just from their initial injuries, but from the rampant bacteria that followed. This urgent need led to scientists at Oxford University, Howard Florey, and Ernst Boris Chain to dust off Fleming's forgotten paper. They were a formidable team. Florey was a determined pathologist and a master organizer, while Chain was a gifted Jewish-German refugee and a brilliant biochemist. Together with their team, they picked up where Fleming had left off. Their task was monumental. They needed to find a way to purify penicillin and produce it on a massive scale. Their laboratory looked more like a strange factory, filled with bedpans, milk churns, and custom-built containers, anything they could find to grow the finicky mold. The work was slow and painstaking. It took them an entire summer to produce enough penicillin to treat a single mouse. Their first human trial was on a police officer named Albert Alexander. He had developed a severe infection from a simple scratch from a rose thorn. Sores covered his face, and his body was racked with fever. He was dying. They began administering their precious penicillin. The results were miraculous. Within days, his fever dropped, and the infection began to retreat. He was recovering. But then, disaster struck. They ran out of penicillin. Despite desperately trying to recycle the drug from the patient's own urine, they couldn't produce enough. The infection returned with a vengeance, and Albert Alexander tragically passed away. While a personal tragedy, the case proved a vital point. Penicillin worked. They just needed more of it. With Britain's resources stretched thin by the war, Florey and Chain turned to the United States for help. In the summer of 1941, they traveled across the Atlantic, carrying a small sample of the precious moldsome smeared inside their coat pockets to keep it safe. American pharmaceutical companies and the US government saw the immense potential and poured massive resources into the project. Scientists launched a nationwide search for a more productive strain of Penicillium **. The winning specimen was famously found on a cantaloupe melon in a market in Peoria, Illinois. This new strain, combined with innovations in fermentation technology, allowed for industrial-scale production. The miracle drug was finally ready for the battlefield. By D-Day in 1944, enough penicillin was being produced to treat every single Allied soldier. It saved countless lives, turning what would have been fatal infections into treatable conditions. It truly was a miracle of modern medicine, born from a moment of chance and a decade of persistence. In 1945, Alexander Fleming, Howard Florey, and Ernst Chain were jointly awarded the Nobel Prize in Physiology or Medicine for their monumental contributions. Fleming, in his humble way, always downplayed his role, often saying, "I did not invent penicillin, nature did. I only discovered it by accident." But his accident was the spark. It was his curious mind that recognized the significance of that contaminated petri dish. The story of penicillin isn't just about one man's luck. It's a powerful testament to the nature of scientific progress, a chain of observation, curiosity, collaboration, and relentless determination. From a forgotten dish in a messy lab to a global medical revolution, the discovery of penicillin reshaped the course of human history, ushering in the age of antibiotics and saving hundreds of millions of lives. It's a powerful reminder that sometimes the greatest breakthroughs can come from the most unexpected places. Thank you so much for joining me on this incredible journey through history. If you enjoyed this story, please hit that like button and consider subscribing for more tales of science and discovery. We'll see you in the next one.